Hello everyone. Welcome to week 7, section 5.5, parallel and perpendicular lines. Parallel lines are parallel because they have the same slope. Okay? That means they climb at the same speed, or if you can think of train tracks, right? The two train tracks run together, same distance apart as long as they go. Well, as far as math is concerned, here's two equations. How do I know if they're parallel or not? Well, the only thing I can look at is their slope. Now on the left side, the equation is y equals mx plus b, so the slope is fairly quick. On the right side, I need to reduce or switch it into y equals mx plus b so that I can see that the slope is actually the same slope. Well, I can write it this way, where it says M1 is parallel to M2. That's the way it reads. Okay, those two lines stick out above the guidelines and below the guidelines, and they signify the term parallel to. All right, let's keep going. So, they're going to give you a point and an equation, and they will write the question that you have to solve in this manner, passing through point and parallel to an equation. All right, so what do I need to do? Well, if they're parallel, the two slopes are the same slope. There's no guarantees that that 1, -5 is on the given line. In fact, I would suggest that chances are this point is on a different line. So what do? I look at line 1, the equation they gave me, and I use the same slope for the generic line 2. So instead of y equals mx plus b, I replace the m with the other guy's slope, right? The reason? They're parallel. Now, if you notice, I have 3 unknowns here, the y, the x, the b, but they gave me 2 of the 3 variables, the x and the y. So when I substitute those in, that leaves me with only b to solve for. Once I solve for b, I now have my y-intercept, I have my slope from line 1, and I have my new equation. Given parallel to the x-axis and passing through some point. Well, if you take a look, here is point P on an xy graph. Now, if I want a line that is passing through point P, but parallel to the x-axis, well, that line would look like the dotted line here. Well, the only way that could happen is if y becomes locked, right? If y is locked, meaning y is 4, it doesn't matter who the partner is from the x side of the equation, right? Y will always be 4. Now the other thing I'd like you to notice is if it's parallel to the x-axis, then it's y equals from that point that it's flowing through. Okay? All right, let's keep going. Perpendicular lines cross at 90 degrees. Okay, well, there's a rule that comes to play. M1 times M2 is equal to -1. That means if I take the slope from one and take the slope from another line and multiply them, they should equal -1. Now, it's nice to have that formula, right? But in practice, the way it works is most people look at the first equation, they look at the first slope, then they look at the second slope to see if it is the negative reciprocal. What does that mean? Well, If slope 1 is a over b, then I need slope 2 to be b over a and opposite, right? If the first one's positive, the second one's negative, and vice versa. So if I take these two formulas, multiply them together, you'll notice that the AB divide out, leaving me with what is -1, proving this formula. Okay, so for example, if it's -5 over 3 and 3 over 5, when I multiply them together, I'm going to get -15 over 15, which is -1. The way we would write it would be M1 is perpendicular to M2. This is an upside down capital T as the symbol for perpendicular. All right, let's keep going here. All right, so let's say they give us a question that says passing through some point and is now perpendicular to another equation. Okay? Well, how do I solve this problem? Well, I'm going to need the first slope that they gave me, right? -3 over 5. And then if it is perpendicular, right, then the second slope is the opposite reciprocal or negative reciprocal. Okay? So -3 over 5, line 2, 5 over 3. Once I know what the second slope is, I'm going to take it. And I'm going to use it in my generic y equals mx plus b. Once I'm here, right? Once I'm here, I'm going to use the only point they gave me, plug in my x and y, and clear it up to figure out what my y-intercept is. Once I have my y-intercept and my new slope, that's the equation. One more thing. What if they said it is passing through 7, 4, and it is now perpendicular to the x-axis? All right? Now notice I've already picked my answer. As soon as they say perpendicular to x-axis, I know that I need x equals 7. Now I'll show you why I knew that so fast. So here's a situation. Here's point P, right? Here's 7, 4, right? But if it's perpendicular to the x-axis, that means this time the x is locked. So if it's perpendicular to a particular axis, it's that particular digit that is locked. When they're parallel, it's the opposite digit that's locked. I have done all my examples as y equals mx plus b. Another favorite trick would be to have put the equations or given you the equations as semi-standard or standard notation. 5x plus 2y equals 10 is semi-standard. So if I need to know the slope, then I need to rewrite the equation from semi-standard to y equals mx plus b so I can figure out the slope. Once I have the slope, then I can do the homework. All right, ladies and gentlemen, here is the homework, seeing that we mentioned it. And like I said before, you can do 1 out of 4, 1 out of 3. Don't do all of these questions, okay? Be selective. Make sure you get one of every type. All right, ladies and gentlemen, have a good day.